What is up, guys? Welcome to Barden. My name is Heinrich, and today we're going to add the ability to jump to our character. Last episode, we set up the finite state machine and got started with our movement and idle states. So to get our jump working, we're going to take a look at our ability superstate, our jump substate. We also need to take a look at our in-air state, and then lastly, we'll look at our land state. So to get started, let's head over to Unity, and let's just go ahead and create the scripts for each of these states. So we can come to our superstates folder, and let's create a new C# script, and let's call it player ability state. After that, we have three substates. Our first one is going to be our jump state. So player jump state. Next, we have our in-air state. So create C# script, player in-air state. And then finally, we have our player land state. We can now go ahead and just open all of those up. And now that we have all three of these open, let's just go ahead and turn them into actual states. So let's start off with our player ability state. We can go ahead and get rid of this code and then just make it inherit from player state, seeing as this is our super state. Next, we have our jump state, which inherits from player ability state. So you can go ahead and get rid of that. Make this inherit from player ability state. And before I actually forget, let's go back to our player ability state and create the constructor. And then do the same in our jump state. So remember, you can just right click, quick actions in refactoring, generate constructor, or hit Control full stop. And of course, that might be different depending on what editor you're using. Okay, next we have our player in air state. So in this case, if we take a look at our state machine diagram, you can see that our in-air state is not a child state for any other state. So it's not a substate or a super state. Currently, there's just no other states that we really need to group this one with. So this one can just be standalone. Same thing goes for our ledge climb, which we're going to get into in a later episode. So in this case, we're just going to inherit from our player state. So get rid of that and then inherit from player state. And then just go ahead and generate the constructor. And then finally, we have our player land state. And in this case, player land state is a substate of our grounded state. So just go ahead, get rid of that, and make it inherit from player grounded state. And then generate the constructor. Okay, so now all of these classes are ready to be states. The next thing we can do is actually set up the state objects in our player script. So let's go ahead and open that up. So we can come and open up our state variables. We have three new states. So our first one is going to be public player jump state, and we'll just call it jump state. And then we give it a public getter and a private setter. Next, we have our player in air state. So public player in air state, and we'll just call it in air state. And of course, don't forget the public getter and the private setter. And then finally, we have our land state. So public player land state, call it land state. Okay, perfect. Now that we have these states declared, we can go ahead and initialize them, or actually create the objects. So that happens in our awake function, which is a Unity callback function. So here we have our idle state and our move state. So next we have our jump state, which equals a new player jump state. We pass this as the player, state machine as the state machine, player data as the player data, and then finally we need to pass it an animation boolean name. Now, by our logic, this should just be called jump. But if you remember from the old controller, we have a set of animations and a blend tree that we play if the character is not grounded and is moving up or down. So the jump animation is actually part of the up animations. So what we're going to do is in the jump state, we'll be transitioning to the same animation state as our in air state. So we can just call our animation boolean name that we want to set in air, like that. So next we actually have our in air state. So in air state equals a new player in air state with this as the player. Again, state machine as the state machine, player data as the player data, and then in air for our animation boolean name again. And then finally, we have our land state. So land state equals a new player land state with this as the player, state machine as the player data as the data. And then finally, our animation boolean name is just going to be land with a lowercase l. Perfect. And that's basically everything set up in the player. So now we're free to transition to any of these states. So let's first take a look at how we're actually going to register the jump. So what we need to do is come to our player input handler. And over here we have our onJumpInput function. So what we're going to do is come up to our variables and create a public boolean. And we'll just call it jumpInput with a capital J, and then give it our public getter and our private setter. And then all we need to do is come to our onJumpInput function and say if context.started. So this means our jump button has just been pushed down. Then we want to set jumpInput equal to true. Then if we take a look at our state machine diagram, you can see that from our move state and our idle state, and really all of these states, if we push the jump input, so we have an ability input, we're going to come to our jump state. That means this transition that's based off of our jump input should come from our grounded super state and not one of our substates. So let's go to our player grounded state, and let's just create a private bool, call it jumpInput. And then in our logic update function, we can go ahead and read that in like before. So jumpInput equals player.inputHandler dot jumpInput. Simple as that. So whenever we push the jump button, it's going to set this boolean to true, and then we'll just read that in our states. So now in our logic update after this, we can say if jumpInput is true, then we can transition to our jump state. So we just say state machine dot change state to player dot jump state. Just like that. Now there's a couple more things we need to do. Let's just go ahead and test this to see if we actually go to our jump state. So when we run the game and we open up our console and then we push spacebar, you can see we change to in air. So yeah, we successfully transitioned to our jump state, but everything is broken now as we have not yet set up the inner workings of the jump state. But we have another problem, and that is once we set this jump input to true in our player input handler, there's nothing that sets it false. So normally what we would do is in our onJumpInput function over here, we would directly call the function that causes the player to jump. But seeing as we're using this whole state machine system to make it so that we can choose when we want to read in our jump input and when we don't, we can't do that from here. But at the same time, we can't just set this to true and then set it back to false, because then we might run into a situation where our state has not had a chance to read this input yet. So what we're going to do is create a function that sets jump input to false whenever we use it. So below our onJumpInput function, let's just go ahead and create a public void, and we'll just call it useJumpInput. This function does not take any input parameters, and it only has one purpose. All we do in here is say jumpInput equals false. Now a neat little thing that I discovered recently, if we have a function that only has one line of code, there's something we can do to make it look a little bit prettier so it doesn't take up so much space. So over here on the left, you can see there is recommended quick actions. And at the bottom here, it says use expression body for methods. If we go ahead and click on this, you can see that the way of writing this in a single line is just saying the function name and then equals greater than, and then what that one line is. So it's saying, when you call this function, just do this. And this is actually quite a nice way to make your code look a little prettier. But again, you could leave it the other way. It's really not an issue. So now what we're going to do is in our player grounded state, before we transition to our player jump state, let's just go ahead and call that function. So we'll say player.inputHandler.useJumpInput. So now basically the jump input gets set to true, and then once we use it, we set it back to false. Cool, so we can now work on our jump state. Let's go ahead and take a look at that. And our jump state is actually very simple. All we do is just set our y velocity. So before we can do anything here, we first need to come to our player data, and let's create a new header. And this header is going to be for our jump state. And the first variable that we want to declare is going to be our jump velocity. So we have a public float jump velocity. And by default, let's just go ahead and set it equal to 15. And now that we have our jump velocity, we still need to create a function to set our y velocity, as we currently only have a set function for set velocity x. So let's go ahead and create that quickly. So we're going to create a public void set velocity y, and this function is going to be exactly the same as our set velocity x. So it takes in a float parameter called velocity, and then inside the function we just say workspace.set, and we want to set it to current velocity .x, and on the y we set it to velocity. Then we just need to go ahead and apply that velocity. So rb.velocity equals workspace, and then we update our current velocity. So current velocity equals workspace, just like that. So now in our player jump state, we can just go ahead and generate our overrides. And for our jump state, we really only need our enter function. So let's just go ahead and generate that. And now in our function, we can just go ahead and say player.set velocity y, and we just want to set it to player data dot jump velocity. So now we can go ahead and quickly test that. We're still going to get stuck in the jump state, but at least we can see the character jump. Boom, just like that. And again, we're stuck. So now we need to transition out of our jump state. So the thing with our jump state is our transition is basically instantaneous. Once the jump is over, we're going to transition to our in-air state. But our jump state is part of our ability super state. So what we're going to do is once we've applied the velocity, we say, okay, this ability is done. And then our ability super state can take over and determine where it needs to transition to now. So let's go to our player ability state, and let's just immediately come and generate our overrides. We don't want the first three, just like that. And so the first thing we want to do is create a variable that is going to be protected, and it's going to be a Boolean, and we'll just call it isAbilityDone. So this is the Boolean that our player ability state is going to use to know if the current ability is done or not. So then we just want to come to our enter function, and by default we're going to set isAbilityDone equal to false. In our player jump state, after we set the velocity, we can then just go ahead and say isAbilityDone equals true. Cool. So now in our player ability state, we just have to transition to the appropriate state. So currently we're going to have two cases that we can transition to. Either when the ability is done, we are grounded, or we are not grounded. In the case of being grounded, we'll just transition to our idle state. And in the case that we're not grounded, we're going to transition to our player in air state. So what we need now is the ability to determine if we are grounded or not. So to do that, let's come back to Unity. And if we look at our old player, we have a ground check game object. So on our player, let's just go ahead and create an empty game object, and we'll just call it ground check. And then the position for ground check, we can just use the same again, is 0 on everything except for y, which is negative 0.941. So that is currently at middle bottom of our player. So on this position, we're going to do an overlap circle to determine if it's detecting ground or not. So this is where our next check function is going to come in. So in our player class, we can go ahead and minimize our set functions and open up our check functions. So we're going to have a function here that's going to return whether or not we're touching ground. So let's just write that above our check if should flip. So we will have a public bool, because this function is going to return true or false. And we'll just call it check if touching ground, like that. And now in this function, we're just going to say return physics2d dot overlap circle. And in this case, we're going to use this version of the function. So we require a point, a radius, and a layer mask. So the point is going to be given by that game object that we just created. And then our float radius and our layer mask are two other variables that we need to create. So let's just quickly go ahead and make those. The first thing we need is our vector2 point. So let's come up to our other variables. And really we can make another region here for all of our check variables, because we're gonna have a bunch of those little transforms that we're gonna use. So let's just go ahead and say hashtag region and just call them check transforms. And then we can go ahead and close the region. So now inside of this, we can create a serialized field, private transform, and we'll just call it ground check. Next, we need the radius of our ground check, so that we'll do in our player data. Let's just go ahead and create another header. This time it's going to be called check variables. And so under this, we'll declare our public float ground check radius. And then next we have our layer mask. So this is public layer mask, and we'll just call it what is ground. Now our ground check radius, we can actually just set to 0.3 by default. Cool, so now that we have that declared, we can come back to player. And then in our check if touching ground, we can start off by passing it our ground check dot position. Next comes our player data dot ground check radius. And then finally comes our layer mask, which is player data dot what is ground. So this function will return true if overlap circle detects ground. So what we can do is in our player ability state, let's go ahead and create a private bool called is grounded. And so in this case, I'm using private instead of protected because I don't think any of my abilities will need to know if they're grounded or not. But again, if you have an ability that does need to know this information, you just set it to protected. We can then come to our doChecks function and just say is grounded equals player dot check if touching ground. And I think a better name for this function, so we can just click on it, click Control R twice, is just check if grounded. Like that. It fits the variable name better. So now with this information, we can determine where we want to transition to. So let's come to our logic update function and we'll say if is ability done, then if is grounded, we want to transition to our idle state. So state machine dot change state to player dot idle state. And then if we are not grounded, so else, state machine dot change state to player dot in air state. Like that. But there's actually something else we need to add here because seeing as our jump ability is instantly over, we're still going to be detecting ground at the very beginning of our jump. So we want to make sure this only applies if our velocity is less than or equal to 0. So we can just go ahead and say and player dot current velocity is less than 0.01 f. And this should be current velocity dot y. So now let's go ahead and test that in Unity. The first thing we need to do is come to our player and drag in our ground check transform. Then if we run the game and we jump, you can see over here we have two cases where it prints out in air. So this is when it goes to our jump state, and this is when it goes to the in air state. Perfect. So this means we can now move on to our in air state. So let's head to that script and let's go ahead and generate our overrides. Boop, boop. Okay, perfect. So now let's think about what we want to have happen in our in air state. If we look at our state machine diagram, you can see that in our in air state, if we get another ability input, so if we push spacebar again and we have the ability to double jump, we'll come back to our jump state. Otherwise, we'll just stay in the in air state, and if we detect ground, we go to our land state. Other than that, we have some transitions down to our different wall slide and ledge climb in those states, but we won't worry about those just yet. So currently the only thing we're going to worry about is our transition to our land state. So in our player in air state, let's go ahead and create another Boolean. So we have private bool is grounded again. Then we can just go ahead and add that to our do checks. So is grounded equals player.check if grounded. So in our logic update function, all we have to do is again say if is grounded and our player.current velocity .y is less than 0.01f, then transition to our land state. So state machine dot change state to player dot land state, just like that. Now another thing we want to do in our in-air state is give ourselves the ability to actually move. So in our grounded state, we have a move state and an idle state, but the main purpose of that is the fact that we have different animations. In our in-air state, it's the same animation tree taking care of all the animations. So it'll also just read in our X input and move the player accordingly. So let's go ahead and declare a variable for our X input. So private int, call it X input. And I'm actually just going to move it above the bool. Then in our logic update, the first thing we can do is read in that X input. So X input equals player dot input handler dot normalized input X. So now we only want to move the character if we're not actually transitioning to a different state. So after this if, we'll just have an else. So we'll say player dot set velocity X, and the velocity we want to set it to is our player data dot movement speed or movement velocity multiplied with our X input. And so what's cool about this is if we wanted a different type of movement when we're in the air, so maybe something that's not as responsive, we could just use a different function here. And before we actually set the velocity, we also want to check if we should be flipping the player. So player.check if should flip, and we just pass it our X input. Okay, let's go ahead and test it. So back in Unity, we just need to click on our player and come to our player data and just set what is ground equal to ground. And then if we run the game and we run and we jump, as you can see, we have now transitioned to our land state when we detect ground. So currently we don't have any of our animations set up yet, so we're still getting these parameter issues, but it's a start. So now before we move on to our land state, let's actually go ahead and set up the animations. So if we go to our sprites folder and look at player, character 1, so there are actually two different jump animations this time. There's one for when we're jumping without X input, and there's one for when we're jumping with X input, and then we just have the same fall animation and then our land animation. So if we just take a look at our old player jump fall blend tree, you can see we have animations jump 1, jump 2, jump 3, where jump 3 is our falling animation, jump 2 is like the middle transition animation, and then jump 1 is our rising animation. So we're going to do something very similar to this, except instead of being based off of one variable, we're going to have two variables here. We'll have our X velocity and our Y velocity to determine which of the starting animations should be playing. So let's go ahead and click on our player. Then let's right click, say create state, new from blend tree. And let's just go ahead and call this the same thing. So this is our jump fall blend tree. Then if we go ahead and click on the blend tree itself, we can set what our blend type is. So currently it's set to 1D, so only one parameter. So we want to go ahead and set the blend type to 2D freeform directional. And as you can see now, it gives us the options of two different parameters. It created this blend one for us. So we can actually just go ahead and rename that to Y velocity. And then let's create another one. So these are floats. This is going to be our X velocity. And yeah, so now we just need to go ahead and create the animations. So we're going to end up with quite a few animations. So let's go ahead and drag up our animation window and head over to our game view. And we can then click on our player and then create a new animation clip. We just have to navigate back to our animation folder, animations, player. And so let's call the first one jump up 1. And then let's create another animation. This time it's going to be jump up 1x. So jump up 1 is going to refer to our first jump frame where we have no X input. So in that case, it's this one. And then jump up 1X is going to refer to this animation sprite. So we have jump up 1, jump up 2, and then jump up 3. So we're going to have 6 different jump up animations. Let's just go ahead and finish declaring those. So we have jump up 2, and then jump up 2X. And then finally jump up 3. And jump up 3X. After that, we have our fall animation, which is 3 different frames, but in this case, all 3 of these are just going to be part of one animation. So next we just have a fall animation, like that. So let's go ahead and drag in all of our frames. Let's start with our non-X animations. So come to jump up 1, seeing as we only have 1 frame, the sample rate can stay at 60. And in this case, it's sprite number 7. Drag that in. That's what that looks like. Next we have jump up 2, which is going to be sprite 8. And then jump up 3 is sprite 9. And now for jump up 1X, it's going to be sprite number 4. Jump up 2X is sprite number 5. And then jump up 3X is going to be sprite number 6. After that, we have our fall animation. And in this case, we have 3 different frames, so sprites 10 to 12. Let's go ahead and drag those in there. And seeing as we have 3 different frames, we're going to want to change the sample rate. I'm going to make it 5. Let's see what that looks like. Maybe a little bit too slow. Let's make it something like 8. Yeah, that looks good. As you can see, it's literally just the same frame, except the little hoodie is waving in the wind. And then our final animation that we need is our land animation. So that's going to be sprites 13 till 16, whereas sprite 16 is just our first idle animation sprite. So create a new clip, and we'll just call it land. And then we can go ahead and drag in these sprites. So sprite 13 to 16. Throw that in there. Doing some mad squats. Change the sample rate to, I guess, 8 as well. Let's see what that looks like. Perfect. So seeing as we're looking at the land animation, let's just quickly talk about what that state is. This state is more so about game juice than actual mechanics. So what happens is when we land on the ground, if we're not giving X input, we finish this land animation. But if we do give X input, we immediately go to our move state. So it just adds a little bit of polish to our movement, if I can say it like that. You'll see once we implement it. Okay, so now that we have all these animations made, we can go ahead and close the animation window. And let's click on our player and then come back to our animator. If we go back to our base layer, you'll see all these animations that we just made. In this case, we can just go ahead and delete all of them except for our land animation, which we can just drag up here. Let's go back into our jump fall blend tree, and then let's click on our blend tree again. And here we have our list of motions, where motion is the animations that we want to use. So let's just click the plus sign and say add new motion field. But as you can see, we currently only still have one slider that we can change. That's because our parameters is currently set to both of them on Y velocity. So let's go ahead and change the second one to X velocity. I think that's the right one. And yeah, now let's go ahead and add all of our motions. So we have 6 jump animations and 1 fall animation. So that's 7 total. So 1, 2, 3, 4, 5, 6, 7. Let's just go to our project window and let's go to our animations folder, player, and let's go ahead and drag in all of these animations. So we'll start off with jump 1, then we have jump 2, then jump 3, then let's do jump up X, jump up 2X, and then jump up 3X. Then finally, let's put in our fall animation. Boom. Okay, so as you can see here, if we adjust the Y and X velocity sliders, it's actually the opposite way around. So the first one should be X velocity, and then the second one should be Y velocity. So now if we change X, that red dot moves along the X axis, and if we change Y, it moves along the y-axis. So seeing as we have our jump velocity set to 15, we want to make our position y for our jump up 1 something close to that but below it. So if our jump velocity is 15, we'll make this say 13. We want to do the same thing for jump up 1x. And then jump up 2, we'll do somewhere between that and 0. So let's just do 8. And then finally jump up 3, we can just leave on 0. Next we need to look at the x-axis. So jump up 1, 2, and 3, all of the x positions should be 0. And then jump up 1x, 2x, and 3x should all be 1. And the reason we don't also have to specify this for a negative x velocity is because we'll just pass the absolute value of the x velocity to this. Next we have our fall animation. So now that I think about it, we actually have to add another motion field that is just going to be our fall animation again. But we just need this here so that we have one for a 0 x velocity. And then our y position is going to be, let's just say -3. And then we need one for when we have an x input and -3 for the y position again. So now if you play around with these sliders, you can see how we transition between the different animations. It's pretty cool. Okay, with that set up, we just need to set up the transition to the blend tree itself. So let's come back to base layer. Here we have our jump fall blend tree. So we should just come up to our parameters, create another Boolean. This time we'll call it in air. Drag that up to the top. Then we can make a transition from entry to our jump fall blend tree. Set the condition to in air equals true. And then we make a transition from our jump fall blend tree to exit. And this time we untick has exit time, the transition duration is 0, and our condition is that in air is false. Now before this will work, we actually need to set our y and x velocity parameters. So let's come back to our in air state, and then in our logic update, in our else function, let's go ahead and pass in the values to those parameters. So after we set the velocity, let's just go ahead and say player.anim.setFloat. And the first float we want to set is going to be our y velocity. And we just want to set this to player.currentVelocity.y. Next, we want to set our x velocity. So let's just go ahead and copy and paste this, change this to x velocity. And now instead of setting it to player.currentVelocity.y, we want to do .x. But we also want to come and say mathf.abs. So if we have a negative x velocity, the animation will still work correctly. Mathf. Perfect. And I think everything should work now, so let's give it a little try. As you can see, our jump animation works. And as you can see, we're in the land state, so we can't move or anything because we don't have any like local transitions out of land state. But because land state inherits from grounded state, we can still jump. So really we can't test the X jump. Let's give that a try. As you can see, it plays the X jump animation, which is really cool. It adds so much. I'm really proud of that. Okay, so now let's take a look at our land state. Our land state script is very simple as well. So player land state. And this time all we need is our logic update function. So let's go ahead and generate overrides, deselect all, select our logic update. And all we need to do here is if we have X input, we transition to our move animation or our move state. And if we don't have X input, we just let the land animation play. And if the land animation is done, we transition to our idle state. So we'll just go ahead and say if X input, which we can do because we're already reading in the X input in our player grounded state, does not equal 0, then state machine dot change state to player dot move state. And now after this, we're going to have an else if, and this is going to check to see if our animation is finished. So we actually have to add something else to our player state script. So let's go ahead and open that back up. We can get it from scripts, player finite state machine, player state. So in our player state script, we're going to create two more functions that we can call from our animations. And you'll see how we do that. So the first one is just going to be a public virtual void. And we'll call this one animation trigger. Like that. So this function isn't going to hold any code inside of it. So we'll just leave it like this. We can actually do the same with these functions just to make them look a little prettier. That's too much effort. I'm not going to do that now. We can take care of that later. But anyway, so we have this animation trigger function. And seeing as we put it in player state, that means every single one of our other states will have this function. And our next function is going to be public virtual void. And this one will be animation finish trigger. Now our animation finish trigger is actually going to do something. If we come up to the top, we can declare a protected bool. So we can just call is animation finished. By default, we can come to our enter function and set that to false. So is animation finished equals true. And then in this animation finished trigger, we can just make that set that to true. So put the little arrow like that and just say is animation finished equals true. And if we do the shorthand, we should get rid of the squiggly brackets. Just like that. Perfect. So now every state has this animation finish trigger function that we can call to let the state know, hey, the animation that you're playing is actually finished. And this comes in really handy. The animation trigger we're not going to use right now, but we just use it if we want to trigger something in the middle of an animation. And we will make use of this later, you'll see. So now how do we actually call these functions from our animations? To do that, we need to come to our player script. And we're going to create those exact same two functions that just call those functions on our current state. So let's open up our other functions. And above our flip function, let's create a private void animation trigger function. And this function is simply going to call state machine dot current state dot animation trigger. So we're basically interacting with these functions the same way we do with our logic update and physics update function. So seeing as the player script sits on the actual game object, we can call this animation trigger function from our animations. So after this, we just have private void animation finish trigger. And again, equals greater than state machine dot current state dot animation finish trigger. Like that. So now in our player land state, what we can do is say if is animation finished, then state machine dot change state to player dot idle state. And now before this is going to work, we have to come back to Unity, come to our animation window, click on our player, come to our land animation, and at the end of the animation, so over here, we just need to add an animation event, and then the function we're going to call is, you might need to scroll down to find it, is our animation finish trigger, like that. So now we just have to come to our animator and actually set up the transitions over here. So we can create another Boolean parameter. This is our land Boolean. Move that up to the top. Then we just make a transition from entry to land. Click on it, set the condition to land is true. Then make a transition from land to exit. Click on that. Untick has exit time. The transition duration is 0. And then the condition is land must be false. So let's give that a try. So if we jump, okay, it doesn't appear to be playing our land animation. Let's see what's happening there. Okay, the land animation finishes really quickly. Let's double check our code real quick. Okay, so I found my mistake, and it's really quite dumb. Back in the code in our player state script, in the enter function, I set is animation finished equal to true by default. We're actually supposed to set this equal to false by default. Okay, now it should work as we want it to. So as you can see, when we land, we slowly stand back up, but if we're running and we land, he just keeps running. Okay, so also our camera is not currently following our player. That's because our player camera is currently following our old player. So let's just go ahead and drag in our new player. This should make it look a little bit better. There we go. There's our land animation, and there we just ignore it. Perfect. Okay, so now we currently still have an issue, a couple of issues. As you can see, if I jump and I spam spacebar, he immediately jumps again once he lands. So that is because we have this code here in our player input handler. Jump input gets set to true and only gets set to false once we actually use this jump input. So that means if we press the jump button in a context where we can't currently jump, it's going to hold on to that jump input until we can jump, and then it'll use that jump input. So we don't actually want this, but we kind of do. If you remember in the old series, we had a thing where we saved the input for, like 0.2 seconds, just in case we push the jump input a little bit too early. That way it doesn't feel like our jump input wasn't registered. We can still use that. So we're essentially doing the same thing here. We're just never setting jump input back to false. So now another thing that we're going to add to our input handler is a timer for our jump input. So what we're going to do is come up to our variables, and we're going to declare a serialized field, private float, and just call it input hold time. So this is how long are we going to keep the input true before we set it to false. By default, I'm just going to set it equal to 0.2f. And then next we need to declare a private float. And this we're going to call jump input start time. So when did we push the jump input? We'll then come to our onJump input function. And after we set it to true, we'll say jump input start time equals time dot time. Next, we need to create our update function. So seeing as our input handler is still a mono behavior, we'll have an update function. And now in this update function, we're just going to check our input start time versus the current time, and then set our jump input to false if hold time has passed. So let's actually create another function underneath our useJump input function. And we'll just call this private void check jump input hold time. And then in this function, we'll just say if time.time is greater than or equal to jump input start time plus input hold time. If this is the case, then we want to set jump input equal to false. So this now means when we push the jump button, our input will be held at true either until we use it or until time runs out. So now before we forget, we just need to make sure we come and call this function in our update function. So if we run the game again and we jump, as you can see, if we push the spacebar while we're falling, nothing happens. But if we push it right before we land, so we haven't technically landed yet, it'll still register it as a jump because it holds it for 0.2 seconds. Awesome. I'm noticing a little bit of an animation glitch there. I think it's from my land animation. We actually don't need this last frame because that's just the first frame from our idle animation. This one. So just go ahead and delete that and then move our trigger one frame forward. Perfect. Okay, so we have some pretty decent jump code going now. Now, what if we wanted to add a double jump? So this is where our number of jumps is going to come in like we had before in the old code. So how we're going to do this is, let's start off by coming to our player data. And in our jump state, let's declare a public int, and we'll call it amount of jumps. And by default, we'll just set it to 1. Then in our player jump state, So we'll come up and declare a private int that we'll call amount of jumps left. So this integer is going to store how many jumps we have left. It'll usually be 1. When we jump, it gets set to 0. If our player data amount of jumps is set to 2, then we'll have the ability to double jump. So in our player jump state, in our constructor, let's actually set this by default to our amount of jumps. So we'll say amount of jumps left equals player data dot amount of jumps. Now we need to create 2 new functions in our jump state class. One is going to be to check if we can jump based on our amount of jumps left. And the second one is going to be used to reset the amount of jumps that we have left. So we have a double jump and we want it to reset once we land. So let's create 2 new public functions. The first one is going to return a bool, and we'll just call this can jump. And inside this function, we'll just say if amount of jumps left is greater than 0, then return true. Else, return false. Next, we need a function for resetting the amount of jumps left. So this is going to be a public void, and we'll just call it reset amount of jumps left. And all this function does is say amount of jumps left equals player data dot amount of jumps. And actually another function we need is a function that decreases the amount of jumps that we have left. So we'll say public void decrease amount of jumps left, like that. And all this function does is say amount of jumps left minus minus. And you'll see why we need this function in just a second. So now what we can do is come to our player grounded state. And here we have a if jump input. And then we can also say and player dot jump state dot can jump. So basically, if the amount of jumps left is greater than 0, then go to the jump state. We also want to come back to our player jump state before I forget, and then in the enter function, decrease the amount of jumps left. So amount of jumps left minus minus, like that. And now that we have the ability to double jump, we should also check our jump input in our player in air state. So let's come up to our variables, declare another bool, call it jump input. Then in our logic update, we'll say jump input equals player dot input handler dot jump input, like that. So now currently we only have a transition to our land state. So we'll add an else if, and the condition in this case is jump input and player dot jump state dot can jump. Then state machine dot change state to player dot jump state. Just like that. Perfect. And now one last thing that we need to do is reset the amount of jumps left whenever we go into our grounded state. So we can just come to player grounded state, and in the enter function, we'll say player dot jump state dot reset amount of jumps left. So now if we go back to Unity and we click on our player, go to player data and set the amount of jumps that we have to 2, we can then run the game. And as you can see, we can now jump twice, but we can only jump after we touch the ground again. Perfect. Now we're basically almost done with this episode. We just have one more issue left. And that is, look what happens if we just run off of an edge. You can see we stay in our idle state. That is because we currently don't have any of our transitions set up from our grounded state to our in-air state. So as you can see, it's a very simple transition. It's just if ground is not detected, transition to in-air. So in our player grounded state, let's create another private boolean, and we'll call it isGrounded. And then in do checks, all we say is grounded equals player.check if grounded. And then in our logic update function, here we have our transition to our jump state. So after this, we just say else if not is grounded, then we want to transition to in air state. So state machine dot change state to our player dot in air state. And this is where our decrease the amount of jumps left function comes in, because when we run off the edge, we don't want to be able to jump anymore if we haven't jumped yet. So if we have a double jump, we want to have one jump left. If we only have a single jump, after we run off the edge without jumping, we can no longer jump. So in the player grounded state, before we transition to the in air state, we will say player dot jump state dot decrease the amount of jumps left. So if we go back to Unity, and let's just set the amount of jumps to 1. If we run off the edge, as you can see, we can no longer jump. Although we're currently getting stuck on the wall. I don't know why that is. I think... Why is this happening? Okay, so that is happening because we don't have our zero friction material on our rigid body 2D or our box collider. So we can just come to project, materials, player mat. As you can see, it's just a simple material with zero friction, zero bounciness. And we can just drag that onto the material slot for our rigid body 2D. That should fix it. Yep, perfect. We have one jump and we can run off the edge and everything works the way we expect it to. Awesome. Now, one last thing that we can take a look at is coyote time. So coyote time is basically when we run off an edge for a split second, we still want to give the player the ability to jump. So just in case he pushes the spacebar just a little bit too late when he meant to jump from the edge. So this is also quite simple to implement. So what we'll do is come to our player in air state and we'll just declare another bool and we'll just call it coyote time. And basically what we're going to say is if coyote time is true and we push spacebar, we want to jump. So currently over here we have else if jump input and player.jumpState.canJump equals true, then we go to the jump state. But what happens is when we run off the edge, our player grounded state decreases the amount of jumps that we have left. So in our in air state, this canJump will return false if we only have one jump. So now instead of decreasing it here in our grounded state, what we'll do is when we transition to our in air state from our grounded state, we'll start the coyote time, and then only once the coyote time finishes will we decrease the amount of jumps that we have left. So that'll give us a split second after we've run off the edge that we can still jump. So currently we have this coyote time bool. All we need to do now is create a function to start the coyote time and then a function to check the coyote time. So after our physics update, let's create a private void check coyote time. And inside this function, we'll just say if coyote time is true and time.time is greater than our start time. So remember, start time is a variable that we have in player state that saves the time every time we enter the state. Plus, and now we need to know what our coyote time is. So we can actually just come to our player data and we'll just create another variable for our in air state variables. So header in air state, like that. And the variable we want is a public float coyote time. And by default, let's just set that equal to 0.2 as well. 0.2 is a really good number. Then back in our player in air state, we just want to use that here. So if time.time is greater than start time plus player data dot coyote time. If this is true, we want to set coyote time equal to false. And then we want to decrease the amount of jumps that we have left. So player dot jump state dot decrease amount of jumps left. Next, we just need a function to start the coyote time. So we'll say public void this time, start coyote time. And all this function does is set coyote time equal to true. So coyote time equals true, like that. And now before we go and call this function, we just need to remember to call check coyote time in our logic update function. So before we read the input, we'll say check coyote time, like that. And then we can come to our player grounded state. And now instead of decreasing the amount of jumps left over here, we'll just come and say player.inAirState.start coyote time, like that. Now if we go back to Unity, we can actually just test this by setting it to a really big number. So over here, our coyote time is 0 for some reason. I don't know, let's just set it to 1. So 1 second after we run off an edge, we should still be able to jump. That might have been a little bit too quick, but it's still, yeah, it's quite noticeable. So if we just set it to 0.2 like we wanted, and we try it out, as you can see, it still works. But if we wait a little bit too long, we can no longer jump. And there we go. Very simple coyote time. Easy peasy. Okay. Now the last thing we have to do to catch up with where we had the jump in our old player controller is our variable jump height. And we'll use the exact same method. We'll detect when we let go of a spacebar, and when we do, if we're currently jumping, we just apply a multiplier that decreases our jump velocity. So the first thing we need to do is come back to our player input handler, and then we can create another public bool called jump input stop. Give it a getter and a private setter. And this time we come down to our onJump input function, and we'll say if context.cancelled, then we set jump input stop equal to true. We also want to come up to our context.started and set this to false. So jump input stop equals false. Simple like that. We can then come to our player data, and in our inAirState section, let's declare another public float. And this time we'll have our variable jump height multiplier. And by default, let's just set it equal to 0.5. Why not? Now in our player inAirState, the first thing we need to do is know whether or not we're currently busy jumping. And then if we are jumping and jump input stop equals true, we want to apply the jump multiplier. So let's come up to our variables and let's declare another private bool called isJumping. Without the brackets, it's not a function, it's a variable. And then we also need to read in our jump input stop boolean. So let's go ahead and declare a variable for that. So jump input stop. Then in our logic update function, let's read in that input. So jump input stop equals player dot input handler dot jump input stop. Now, once we know this, we'll just say if isJumping. So if that is true, then if jump input stop, so we have that input, we want to decrease our y velocity. So we can just reuse our player.setVelocityY function. And this time we'll just set it to player.currentVelocity.y multiplied with our player data dot variable jump height multiplier, like that. And the reason we have this the ifs nested like this is because we want to say else. So if jump input stop is not true, we want to check if we're still currently jumping or not. And the way we check that is actually by having an else if and not just an else. And then inside the if we say player.currentVelocity.y is less than or equal to 0. So if we were jumping, but our y velocity is now negative, that means we're no longer jumping and we're just falling. So don't decrease our y velocity if we let go of the spacebar. So inside this function, we'll just say isJumping equals false. And if we wanted to, we could extract all of this code into a separate function just to make it a little bit cleaner. So let's actually do that. We'll just create a private void check jump multiplier. why not? And let's just take this whole if statement, cut it from here, put it in here, and then let's call this function up here. Perfect. So now the last thing we need to do is actually set isJumping equal to true to begin with. To do that, we'll have another public void function like our start coyote time function down here. So public void, and we'll just call it set isJumping. And again, this function only does one thing, so we'll say isJumping equals true. Then we want to come to our player jump state, and after we set our velocity, we'll say player dot in air state dot set isJumping. So this is only going to get set once we jump. If we save this and give it a try, you can see if we hold spacebar, we jump all the way, and then if we let go quickly, we have a very short jump, but we seem to have a little bug. Let's take a look at our code, and I think it has to do with our check jump multiplier. So, okay, so we also need to set isJumping equal to false after we decrease the y velocity. So isJumping equals false. That way, this only happens once. As you can see, if we just tap spacebar, we get a very tiny jump. If we hold it, we get our normal full jump. And so yeah, that's a very simple way for us to implement a variable jump height. And I think that's going to do it for today. So just a little recap. We now currently have the ability to jump. We have an in-air state that allows us to move in the air. And then once we hit the ground, we land, or we just keep moving. So we're really on our way to getting our character back to where he was before. In the next episode, we're probably going to start working on the wall jump, which is not something that we currently have. But yeah, we have a pretty good start to our character again now. We can move, we can jump, all the basics. So that's going to do it for now. Before I go, I would just like to thank all of my supporters and wonderful people on Patreon. And a huge special thank you to Triac, Cody Lee, Pyrsays, and Miguel Gray for your support on Patreon. You guys are awesome, and I hope you guys all have a wonderful day.